Hi everyone, my name is Faris from NSU. Welcome. Today, I will be going to dive into a powerful combination using Ansible scripts, specifically within our server automation environment, to streamline the critical tasks of database discovery and patching. This is not just about automation. It is about making these processes more efficient, standardized, and less prone to manual error. Here's a quick roadmap of what we'll cover today. We'll start with a brief summary of Ansible itself for those who might be new to it or need a refresher. Then we'll look at the architecture of how Ansible script works and how they integrate seamlessly with the SA. And then I'll showcase the specific scripts we've developed for both discovery and patching. And then we'll discuss on some important server automation components that are essential for these scripts to function effectively before we move on to the demonstration. So what exactly is Ansible? At its core, it is an automation tool that helps automate various IT tasks, such as provisioning software and managing configurations to deploy applications, for example. One of its biggest strengths and why we're focusing on it today, it's its human readable nature. Playbooks, which are basically scripts, are written in YAML, making them very intuitive to read and write, even for those without any programming backgrounds. It was developed by Red Hat and has a vast active community, ensuring that its continued development and support for years to come. To understand how Ansible works, let's look at these three core components. First, we have the control node. This is your master machine, which is a server from which you execute your Ansible playbooks or scripts. It manages and controls the entire automation process. Next, we have the inventory. This is like a list of your managed nodes or hosts. It's essentially a database of the servers you want Ansible to interact with. It tells Ansible where to run the automation. And finally, the playbook. These are the heart of Ansible. A playbook is a script repo, which is basically a library that contains all the instructions, tasks, and configs that Ansible will execute on your target servers. Now let's look at some example use case. While Ansible is incredibly versatile, today we're going to focus on database patching. But Ansible is equally powerful for software provisioning and config management across your infrastructure. I will be explaining on how Ansible architecture works. First, here's the control node, which is the master machine where it automates or orchestrates the workflow of the Ansible components. And then these are your target hosts or your servers. The user runs an Ansible command or a script from the control node. It reads the playbook. This control node reads the playbook to understand what actions need to be performed. Simultaneously, the control node consults the inventory to determine which specific hosts are the targets for these actions. And then the control node establish the secure connection to these servers or hosts. It then pushes the modules or the right commands to the host, all in one streamline. The results are sent back to the control node and then reports the outcome of the automation. It prints out the outcome of the statements. So that's the summary of the entire workflow of Ansible. Let's dive a little deeper into the structure of these Ansible scripts or playbooks. As you can see from the screen, They are written in YAML or YML, which stands for YAML and Markup Language. Its primary goal is to be incredibly clean and human readable for structured information. As the slide says, uh, it's designed for humans to read and write easily, which is a huge advantage when you're automating complex tasks like database patching. As you can see from the image on the right side, it is an example of the script, which is to retrieve the hostname of the server and print out the statements. Let's break down on what these commands do. Number one, it defines the name of the script, simple and descriptive. Line two, it specifies the target host or the server group this script will run on. Number three, tells Ansible to collect system information from the target, which can be useful for conditional logic later. List four, this is where you define the list of tasks to perform. Number five, it defines the name of the specific task, or as you can say, like an action on what the script will do. Number six, debug is an Ansible module which prints out the output during the execution. And number seven, this is a parameter for the debug module. It specifies what the message to display. So in this case, the hostname of this specific server will be print out. So as you can see, even without any Ansible experience, the logic is very straightforward. Ansible in server automation. It's integrated to extend its automation capabilities. It is an out-of-the-box integration in SA. It allows users to leverage Ansible playbooks directly within the SA infrastructure. It acts as management and execution platform for Ansible. We have developed two primary categories of Ansible scripts that we'll focus on today, specifically for database, which is number one, discovery, and number two, patching. First is the discovery scripts. Discovery script gathers critical information about your active database properties. The key benefit here is that this information can be stored as custom attributes within the server automation. It is easy to review, it is easy to organize, and is prerequisite for patching. And number two, patching scripts. These are automated scripts designed to apply updates to your active databases. The goal of this script is to standardize and streamline the often complex and error-prone process of the database patching. Here is an example of the database discovery script, which is structured similarly like the example from the earlier parts using YAML. And this is an example of the database patching script. Our developed scripts are designed to be broadly applicable across common enterprise database and OS environments. So for databases, we support MySQL, Postgres, Oracle, MSQL, and DB2. As for operating systems, we support Windows, Red Hat, AIX, and Solaris. This wide support ensures that we can cover most of the existing database infrastructure with these automated solutions. Before we dive into the demonstration, it's very vital to understand two key SA components that are essential for these Ansible scripts to work effectively. As you can see, these components help bridge the gap between generic automation and the managed environment of SA. They are custom attributes and software policies. Let's start with custom attributes. In SA, a custom attribute is essentially a user-defined data element. It allows you to store additional specific information about your managed entities, whether they are your servers, your server groups, or even policies. So in layman terms, you can call it as a custom sticky note, which you can attach to anything in SA. For example, the discovery script populates the custom attributes with information like a database version, its SID, its patch level, and more. This helps us to store and organize data, the database information, and we can use it to have easy review, reporting, and crucially targeting our patching scripts. Next, we have software policies. A software policy in SA is essentially a blueprint or a rulebook for what the software and the configs should be on your servers. It defines the desired state of your environment. You can call it a blueprint for how the server or a group of servers should be configured or what software should be installed. So for our use case, for example, you will insert the specific database patch file information, such as the file name or the specific patch ID into the software policy's custom attribute, and then you attach this policy into the target server. This ensures that the correct patch is associated with the correct database environment. Why are these SA components so important, and why do we need them to execute our Ansible scripts? Much like Ansible needs its inventory and playbooks to be defined correctly, the users have to declare this critical information correctly in the SA client. Let's say in some scenarios, there are different environments, say a development environment and a production environment. So they might have different databases or they have same databases, but it requires a different patch versions or other methods, for example. Without these SA components, it will be difficult to patch safely. So the user has to attach the correct patch information using software policy. Even so, the scripts were developed with this in mind to be flexible, dynamic, and require less manual intervention once these foundational SA components are set up correctly. They read the necessary context directly from SA. With that in mind, I'm going to walk you through how we use server automation to initiate the Ansible discovery script and see how it populates the custom attribute, and then it will simulate a patching scenario. Let's switch over to the SA client. This extension will install all the necessary components, such as the Ansible runner, the core, and also the required Python scripts, which is crucial for the Ansible tool to run properly. Once done, you have to import your Ansible scripts. On the left pane, go to library, by type, scripts, name your Ansible script according to the content. For example, right now I'm going to import the Oracle Discovery Ansible script. So I'll be naming it as NH2 Oracle Discovery. So I will be storing this location to this folder. I made it to not change server, and then I will run it as superadd. Navigate to your Ansible script in your folder, and then click open. It will automatically fill the script content inside of this panel, and then write any description you want. For me personally, I will fill in what this script does and what does it do. Once done, you have to save your Ansible script. Either Control S or you can click on File and Save Script. we need to import the database patch files into the SA repo. Go to your folder location in the SA client, right-click and import software. Navigate to your patch files. Make sure to mark this file type accordingly. For this, I will be selecting zip. I make sure to have it as all platforms for on Red Hat. And once done, click import. In this part, we have to create the software policy to attach the patch file attribute. Click on custom attributes on the left panel. Add 2 new custom attributes and name them according to what type of DB it is, and then fill in patch ID and patch name. To retrieve the value of this, you have to go to the patch file properties. So you open up the patch file properties. As you can see, you have to look at the file name and object ID. So for our file name, right click, Control C, copy, and paste it in the value option. Same thing goes for patch ID, which is the object ID in the patch file properties. Make sure to save the properties. And save the software policy. For this discovery, to run the discovery script, right click and press run. Click on the targets, click on the plus symbol, select the target host, and start the job. So this script will run, and depending on the environment, it will take some time. So once succeeded, you can check your custom attributes in your server. Open up the server. On your left panel, click on custom attributes, and it will automatically fill with your database information. For patching, make sure to attach your software policy. Select on the correct software policy according to your database and your OS. So this software policy will attach the correct patch file attribute. So select the patching script, click on run. And start the job. Depending on your environment, it will take some time. So once succeeded, the script will automatically patch. To make full use of this process, you can rerun the discovery script again. Then go back to your server properties, click on refresh, and the attribute will automatically update according to the latest discovery script. As you see, combining Ansible's powerful automation capabilities with SA's robust management provides a comprehensive solution to manage your database environments. We are continually working to enhance these scripts and expanding support. Thank you, and have a good day.